In this video I am going to explain you what is the role of concept hierarchies and the measures and their categorization and the computations in the data warehouse. Yes, what is concept hierarchy? In the previous videos I have posted what is data cube and what are the dimensions, multiple dimensions that we can have in a data cube. So here a concept hierarchy defines the sequence of mapping from a set of low level concepts to higher level. What is this low level concepts to higher level? See, elaborate, if I want to go into deep of any data, then I will go to the lower level. If I want to see the summarized data, undetailed data, overall data, then I will be at the higher level. See, if I want to calculate the sales with respect to every office, every city, then it is detailed data. But I want to calculate the sales of all the regions, sum of the sales in dollars or in rupees of all the regions. Then it is summative, summary of the overall data. Then it is not that much detailed, that is just summarization. So that will be at the higher level. Lower level means it is going inside, deeper and deeper. If you take the regions, if I want to calculate the sales of all the regions, then all is at the highest level. No, I want to calculate the sales in dollars of all the regions with respect to the regions. Then it is second level. Then with respect to regions means Europe, North America, this and all. Then no, I don't want with respect to region, with respect to countries. If you take Europe, Europe has Germany, Spain and so many countries. If you take North America, again it has some divisions, Canada, Mexico, everything. Then if you take Germany, then if I want to calculate the sales in further deeper, then with respect to the city means Frankfurt, inside the Germany, Frankfurt or something else, inside the Spain, whichever cities are there, inside the Canada, whichever cities. For everything we have to calculate, for every city we have to calculate the sales separately. Then comes office. Then office means in the every city, whichever the offices are there, what is the sales with respect to the office. So that is again going in deeper. So this is the lowest level, office is the lowest level and the highest level is all. So it is going deeper and deeper and deeper inside. So this is nothing but concept hierarchy. It forms hierarchy from all, again one level deeper, again further one level deeper, again still another level deeper, and it goes to the lowest level. It is nothing but concept hierarchy. Next comes data cube measures. How we are going to measure the data cube? So we have three types in it. One is distributive, other one is algebraic, and third one is holistic. In the distributive, what we are going to do is, we are going to measure is, how we are going to measure is, we are going to calculate, if I want to calculate the sum of all the data, sum is nothing but if I want to calculate the sales, total sales in dollars, then what I have to do, I have to sum all the sales amount. Clear? With respect to anything, with respect to location or with respect to item. Okay. So what is distributive here? Here if I have some 500 data, 500 rows, and if I am going to partition it into I am going to partition the data into 5 different partitions, 5 different divisions, and I am going to apply the function called sum. So I will be getting 5 sums. Again I have to do the sum of these 5 sums and I will get the total value. So the distributive is nothing but, distributive function says that whatever answer you are getting before partitioning and applying the function, and after partitioning you get the value which you are getting after partitioning and applying the function, it should be same. See, when you are having 500 values without partitioning and applying function, the sum is, we are applying the function called sum, will assume the value is 5000. This is before partitioning. Now I am partitioning the 500 rows into 5 partitions. So 100, 100, 100. So what I will do, first I have to apply this sum function on the first 100 rows, then second 100 rows, third 100 rows, fourth 100 rows and fifth 100 rows. So whatever the answer I am getting, again I will be applying the function on these 5 answers and I will get a final value. That final value and the value which I got before partitioning after applying this sum function, that should be same. That is nothing but distributive. If the result derived by applying the function to n aggregate values is same as that derived by applying the function on all the data without partitioning, is nothing but distributive. Clear? Next, algebraic. If it is computed by an algebraic function with m arguments, each of which is obtained by applying a distributive aggregate function S. See, if I want to calculate the average of my marks, then what I will do, I have to first total the value divided by number of subjects. Total marks of all the subjects divided by total number of subjects will give me average. So what is the honest method to, or what is the easy method to go with the average for performing the average? We can directly apply the average function on the values and we can get the answer. That is the easiest way. And one more way is there to get the same average value, and the other is apply the total function on the values divided by n, which is distributive functions. Clear? Total by n. Either you can go with the function called average or you can use the functions total by n. Total function, the function called total and the n. Total divided by n also will give you the average. So that is nothing but algebraic. Algebraic says that if it can be computed by an algebraic function with m arguments, each of which is obtained by applying a distributive aggregate function. Whatever the answer you are getting after applying the average function, you should get the same value when you are going to use the distributive aggregative functions. What are the distributive aggregate functions? Total and the n. Total divided by n is nothing but distributive aggregate functions. Next is holistic function. If there is no constant bound on the storage size needed to describe a sub-aggregate, there is no constant value. See, if in data warehousing we have large volume of data, if there is no limit on the storage size, it will be keep on extending, then we have to go with the function called holistic function. For the large volume of data which doesn't have any limit, we have to go with the function measure called holistic. So the data cube measures, in the data cube measures we have 3 categories. One is distributive, algebraic, and third one is holistic. Hope you have understood better. With this I am ending my session. Thank you so much.